All right, hey everybody. Hope you guys are okay. We're gonna do a couple notes or one thing of notes here for the one of the worksheets this week, as well as three of the odd problems. So you should have something to write on, something to write with here. For this section of notes, this is on volumes of pyramids and cones. Basically, just like in class, you'd have this form on the board. This is the formula for volume of pyramids and cones. So please write this down. It's V equals 1/3 B times H, where big B is the base area and H is the height. Be quiet for like 10 seconds here. Please be writing this down. Yeah, and as you can see, guys, it's very similar to the last formula. When we talk about cones and pyramids, we're basically just talking about a three-dimensional object that has a pointy top. Something that like a three-dimensional object with a flat top, we call those we call those cylinders and prisms. Pointy top, we refer to as pyramids and cones. So that's the difference. If you're wondering, well, wait, why does that formula work? I'm going to keep 100 with you always. I don't know the derivation of it. If you Google why does this formula work, you can certainly figure it out yourself or see a proof of it. But for this worksheet, we're just going to practice using the formula. So this is a question you might see on the SAT, ACT, something like that. Yeah, so that's the formula we're going to use here, guys. And let's do numbers 1, 5, and 7 together. Let's do number 1 first. So same idea before, guys. For homework is numbers 1 through 14. I think they're all fair game. The worksheet's posted on Edsby. The answers are online as well. Please check your answers. Don't just send me a worksheet with the answers. I'm kind of worried what happened there. If you have a printer, I would print this out. If you don't have a printer, I'm not gonna lie to you, it's kind of hard to draw these pictures. I tried and failed on number 5 multiple times. I've given up. You'll see that when we get to number 5. My number 1 I could draw okay, but if you can't draw, don't sweat it. At least you should be using the picture to do the problem anyways. So if you can't draw, don't sweat it. If you can, I mean, maybe you want to practice drawing, you can try. But anyway, so here's number 1, guys, and we have a cone. So again, pause the video here. If you want to draw, you can. And you might say, well, okay, well, why is this cone going left to right? Usually we think of like cone sort of like a wizard's top, you know, on going kind of vertically. This one's going laterally or horizontally. We could rotate it. It's still going to be a cone. So we actually are going to use the formula V equals 1/3 base times height. I know I'm using this formula because whenever I have a pointy top, I'm always using this formula. So big B refers to the area of the base. Pause for a second here, guys. What shape is the base of this solid? It's actually going to be a circle. Hopefully you said that. The base, that's the base. Just because it's on its side doesn't really matter. It's on its base. The base is the part that's kind of, you would say, parallel to a vertical plane on the point. If that makes sense. That's the base of the solid. So the base of this cone is a circle. And we know the area of a circle is pi r squared. In this case, r is 2. So I'm going to say the circle area is pi r squared. And the radius is just the distance from the center of the circle to the outside edge, which in this case is 2. So it's going to be pi times 2 squared, which is going to be 4 pi. I understand if you use your calculator that can round to another number. I kind of like leaving it in terms of pi. It's more of an exact answer. Okay, so the formula is 1/3 big B times H. We know the base is 4 pi. To figure out the height is the distance from the base to the very top of the shape. So in this case, the height is going to be 7 because that's from the circle all the way to the pointy top over there. So H is 7. So I've got big B, I've got H. I'm just going to plug it in the formula. V equals 1/3 times 4 pi times 7. That actually is not going to reduce. I can multiply the numerators. 1 times 4 times 7 is 28. 28 is not divisible by 3. So I'm just going to leave it as 28 over 3. Pi is still up there. And this should be meters cubed because we're 3 dimensions. And again, if you want to use your calculator and turn that into decimal, that's fine. But that's a perfectly reasonable answer as well. So again, we're trying to find the volume. Again, when I say volume, I mean how much, if we're going to fill this thing with liquid or have like an ice cream cone, trying to see how much ice cream can you fit inside the cone, that's what we're talking about volume. I'm not talking about how much around is it. I'm saying how much space does it take up. If you're looking for applications of this, let's say you had your own business and you're trying to figure out the cost that it's going to be for like air conditioning for your business, you would kind of need to know how much space your business or warehouse or whatever takes up, and you could then use that to help you figure out the cost in terms of, because you don't know how much it costs to power your business, it's going to affect your bottom line. So this is kind of a simple example. Real world examples tend to be a little bit more complicated. Okay, let's do another one here, guys. Let's try number 5. 5, I tried and failed multiple times to draw that picture. Just not going to happen. If you can do it, more power to you. I cannot. I definitely see that it's got a pointy top, and I know that the volume for any pointy top or any pyramid is called 1/3 base times height. And if you look at number 5, you'll notice that the base of number 5 is a pentagon. I'll draw the base here, but that is a rough pentagon, but that's what we got. So the base of the shape was a regular pentagon. Once again, we go back into our well here and say, well, wait a minute, what's the area of a pentagon formula? Because it tells me on the problem that all of the sides are the same, I'm going to use that 1/2 AP formula. Because again, I'm trying to figure out the base of the base area. I'm going to multiply by the height. I'm essentially going to divide it by 3, and that's going to be the volume. So the pentagon area, it's going to be 1/2 AP. And recall from before, A is the apothem and P is the perimeter. So you have to look at that pentagon on number 5 and recognize that the apothem is going to be, this is embarrassing, I'm not sure what the apothem is. 1 second here. The apothem is 8.3. We're back. That was awful. Apologies. And the perimeter is all the sides put together, and each side is 12. There are 5 sides. So the perimeter is going to be 60. And so to get the area of the pentagon, so again, I'm trying to find the area of the base. The base is a pentagon. Because all the sides are the same, I'm using this 1/2 AP formula. I can see in the picture that the apothem is 8.3. I figured out the perimeter was 60 because 12 times 5 is 60. Okay, I'm going to put them all in the formula to figure out big B. So big B equals 1/2 times 8.3 times 60. I'm going to use my calculator because I'm not going to be able to do that in my head. So 0.5 times 8.3 times 60 is 249. And that's the area of the base. The height of the 3-dimensional pyramid is 11. You can see on the picture that the 11 is the distance from the base pentagon all the way to the very top. So yeah, start with this formula. And just as an aside here, guys, just go off topic because I'm not going to have time for the last problem anyways. Math at a real world level is not this simple. If you're going to go ask a bridge engineer, hey, what formulas you use, they might not just use this formula, but in order to do that, you got to start somewhere, and this is where we start from, okay? So if your question is, well, can I go build a bridge right now? No, not yet, but if you want to do that at some point in life, you got to start here, you got to be good at this, and then work your way up. But anyways, the volume is 1/3 big B times H. Here, we figured out the base was a pentagon. We figured out that its area is 249. Figure out the height of the shape was 11. So I'm going to multiply all that together. Once again, not able to do this in my head. Can I do this in my head? No, because, well, 11 goes 1/3 of 249. That's just 83. So 83 times 11, 830, 913. I think it's 913. I'm going to check on the calculator. I think I got that right. This would be awesome if it's just way off. 249 divided by 3 times 11, 913, great, go me. And we'll say units. I forget what the units were, but it's just units cubed. All right, I'm gonna do one more video, another example, another video, guys. Hope everyone's doing well. I'll see you in the next video.